This is a poster presentation. The title is Communicating Climate Change Science to Drive Political Will. It's for the AGU fall meeting of December 2023. I'm Peter Carter, Director of the Climate Emergency Institute. And a big quote from NOAA: "We are committing Earth and ourselves to climate chaos for thousands of years," and that is because of feedbacks, amplifying feedbacks, including very, very large sources of feedbacks, notably permafrost and wetlands, and the slow feedbacks, notably the ice sheets. And that's from NOAA, October 2023, Power of Greenhouse Gases, an annual publication that they do. So these two lines here are sort of short form for conclusion and recommendations. The IPCC AR6 says, in fact, that global emissions of carbon dioxide and methane have to be put into immediate rapid decline. So I'm going to start with the two central quotes here. This one is the COP28, and this was the statement by the IPCC chair, Jim Skier. This was at the ceremonial opening of the COP, the big first plenary. And in his statement, he said that without immediate and deep emissions reductions across all sectors, we will not meet the goals of the Paris Agreement. Now, this is not a new statement. It was made by the previous IPCC chair, Hossein Lee, this is from October 2021, United Nations COP26 in Glasgow. And it's from the then chair, Hossein Lee of the IPCC. His quote at that time was, "Global warming of 1.5 C and 2 degrees C will be exceeded unless immediate, rapid and large-scale reductions in greenhouse gas emissions, especially carbon dioxide and methane, occur." So running along the top row of the poster here, I've got sort of the most dramatic, most important aspects of the presentation. So here we have fossil fuel subsidies. This is from the IMF, the International Monetary Fund, and this year they published again another estimate of fossil fuel subsidies, including all of the financial and economic incentives that governments allow on the fossil fuel industry. So they're very, very high, and they are rapidly increasing. This one published this year, this assessment by the IMF was on 2022, and the fossil fuel subsidies came to $7 trillion. So, I hope you'll agree that on any ethical, moral, human standard, governments giving $7 trillion to the fossil fuel industry when our planet is being degraded, polluted, and destroyed by the fossil fuel industry, that's a most evil situation. So here's another all-important one, of course. This is one of the indicators, but this is greenhouse gas emissions. This is from a paper published June this year, 2023, an Indicators of Climate Change, an update by Forster. That's along that reference is along the bottom there. So this is all of the greenhouse gas emissions to 2022. So, of course, the big one here is carbon dioxide. This is CO2 from fossil fuel and industry. This is the additional CO2 emissions from what's called land use changes, forestry and other land uses. Next up here in the blue, that's methane. You can see that all of these greenhouse gases are increasing rapidly right back from 1970. The little nick there, that's the short COVID dip. And the emissions were rebounded rapidly, as you see, by government financing, a lot of government financing to the fossil fuel industry. The one here in brown, that's nitrous oxide. And then the top one here is the called F gases. These are industrial synthetic gases. They are by far the most potent and long-lasting of the greenhouse gases. The F gases are actually increasing faster than any of the other greenhouse gas emissions. All greenhouse gas emissions are increasing. So this is one of two exceptions we've got in the presentation. This is actually a future estimate, but it's really important. This is from UNEP and a couple of other intergovernmental organizations, and the report is called the Production Gap Report, and that refers to the production of fossil fuels. And so the shocking conclusion from this one is that governments have plans to increase fossil fuel production to 110% above the 1.5 degree C limit by 2030. And their plans, the same plans, are 70% above the 2 degree C limit by 2030. And so that's an evil situation, clearly, as well. So down here in this vertical row, we've got the temperature, the heating, and this is right up to date. This is the most recent global average temperature increase record published by the WMO here, and there's all the several climate centers, and this is 2023 up to November. And the WMO estimate is that the global warming this year is plus 1.4 degrees C, so very close to 1.5 degrees C. And because of the extremely high temperatures this year, it is a foregone conclusion that this year, 2023, will be a record global warming year by a large margin. This one here is really, really important. This is the summertime temperature increase. We're always provided with a global average temperature increase, which is not a great metric by itself, but with respect to temperature, what of course we really need is the summertime. That's when we have our heat waves, that's when we have forest fires and droughts. So this is the summertime up to 2023. So that's the big, huge jump increase in 2023. We do have El Nino having an influence now, an extra warming influence. However, very clearly this is accelerating, and very clear in this case that from 1960 and on, this is an acceleration, and there's a recent acceleration very clear here. This is extreme heat. This is from the BAMS, and 1950 up to 2022. Extreme heat is increasing on an accelerating basis. And the increase since 2010 is at a higher rate than previously. So we go along here. This is also from BAMS. This is extreme heat. It's called warm days. You can see these are anomalies, so these are changes in temperature, and taken from a baseline of 1991 to 2020. So glaringly we see most of South America, including the Amazon there, the south and the west of the United States, going up into the far north of Canada, Northwest Territories, where all the fires, the monumental record fires, were burning this year. Africa, Northern Africa, and Central Africa here. All of Europe, as you can see, had a big increase in extreme heat last year, 2022. Also China there, and other countries in South Central Europe, Mediterranean region. So a lot of extreme heat in 2022. So along with extreme heat, I've got the map of drought from the BAMS again. These are changes in PDSI, the Palmer Drought Severity Index. The baseline is 1901 to 2022, so the brown is drought, of course. So again, a lot of drought in South America, Argentina there, and up into Brazil there, again including the Amazon rainforest. A lot of drought in the United States and North America here, particularly the west, central, and southern U.S. A lot of drought affecting all of Europe here, and a bit of drought in northern China, which is an agricultural region, and southern Africa had drought, and there was also drought in Australia. So a lot of very deep and very extensive regions affected by drought last year. This is a future projection, so this is an exception from this particular presentation, but it's crucially important. This is from the US EIA, their Energy Information Administration. This is the annual report of the World Energy Outlook, which is called their International Energy Outlook. And I just want to show you that the projection they project to 2050 that CO2 emissions will not have declined, they will not have plateaued, they'll be higher than in 2022. And they'll be 15% higher from the reference case that says REF, and the reference case is the current policies and regulations. The IPC 6th assessment, their working group 3, projected that at current policies and regulations, the world is headed for a warming of 3.2 degrees C this century. So there's the indicators for the ocean here. The first one is ocean heat. Now, most of the more than 90% of the heat accumulated from our greenhouse gas emissions goes straight to the oceans, and it's very, very obvious that ocean heat content is increasing at an accelerating rate, and this is confirmed by NOAA, for example. So this is the record of heat content running from 1983 to 2022 from the BAMs. This is ocean acidification. This is from Copernicus. Acidification is measured as pH, hydrogen ion potential, which is the inverse of acidification. So the report here shows the pH declining. It is clearly declining at an accelerating rate, and this is also confirmed by Copernicus and others. So I've just inverted this so that you can see the relative acidification. So the oceans are acidifying rapidly at an accelerating rate. So rapidly, in fact, that it's faster than anything in the past 300 million years. This is deoxygenation. The ocean is being deoxygenated. A very large contribution to this is the ocean heat content being increased, and this results in stratification and a reduction of vertical mixing. So this is very, very bad for the oceans. And you can see a rapid decline in deoxygenation, again at an accelerating rate. This is from the top world expert on deoxygenation on oceans, Ito et al. And this is a depth up to 1,000 meters. And so here we have sea level rise. This is from BAMS again. And sea level rise is increasing rapidly, and it is rising at an accelerating rate. So this row here, this is the atmospheric greenhouse gases. This is atmospheric carbon dioxide concentration. It's from the Scripps Institute, Mauna Loa, and it runs from 1958. Currently in November of 2023, the seasonally adjusted mean atmospheric CO2 is 422.48 parts per million. That's actually a 151% increase from pre-industrial. So there's a very dramatic, rapid increase in CO2, which of course is the main contributor to the heating of the planet, and also the sole cause of the ocean acidification that we've just looked at. So I put this little box in to show the end, that in actual fact it's the rate is increasing over just the past few years as well. Next we have methane here. This is from Mauna Loa as well. This is NOAA. This is a graph in an important publication by Ewan Nesbitt this year, 2023. He explains the varied rate of methane increase. There was a plateau from 2000. Methane didn't increase, and then 2006 it started increasing again, and then at a higher rate of increase from 2013 about, but over the past couple of years there's been another increase in methane concentration. So this really could be described as an explosive increase. Methane has never increased faster than this. And this is of huge concern because the scientists have all agreed that this big boost in atmospheric methane is actually from feedback. It's from wetland feedback emissions, and all of the world's wetlands are emitting more methane due to global surface warming. This is from NASA. This is a satellite image, and this shows all the wetlands. So we have tropical wetlands, and they're emitting more methane, but also the northern and subarctic wetlands are emitting more methane as well. So this shows this methane map is from September 2021, so it's recent. The bottom one here is nitrous oxide, the third on the list of importance on global warming, but they're all important in so much as they all have to be mitigated, controlled. Emissions of them all have to be cut to near zero, according to the IPCC, in order to stabilize the climate. So nitrous oxide cannot be forgotten about. Nitrous oxide is also now the main chemical causing stratospheric ozone depletion. So this is the atmospheric CO2 equivalent. This is all the main greenhouse gases accounted for together. This is from NOAA. This is their annual greenhouse gas index that they publish every year. So this is the most important publication. And so you see a long-term acceleration of atmospheric CO2 equivalent from 1980. It soars upwards, but it's also recently increased. So there is an acceleration here, and there's also a recent increase of that just over the past 2 or 3 years. The atmospheric CO2 concentration last year was 523 from the NOAA, and they also include in this publication the radiative heat forcing as well. So I'll go to this bottom one here, this colorful one of the radiative heat forcing. This is from BAMS again. This is increasing at an accelerating rate, most definitely, and over the past few years there's some increase in that rate as well. So radiative forcing is the heat added to the climate system, added to the planet. Most of it comes from carbon dioxide, CO2 in blue, and then next in brown is the methane. Yellow is nitrous oxide here, and in red here is the F gases. So you can see that the F gases, the synthetic, very potent gases used in industry, they contribute a great deal into the heating of the planet, the radiative heat forcing. And over the past few years, again, they are increasing faster. And they're actually increasing at the fastest rate of all the atmospheric greenhouse gases. Luckily, they're present in a very tiny proportion, but it is a great concern that they are increasing. The Earth's radiation balance. This is from the NASA satellite series. This gives us the indication of Earth energy imbalance, which is of basic fundamental importance, not only to global warming, but to ocean heating and all of the heat and energy added to the planet. So this is published from NASA, 3rd of December this year, 2023. And the red line here is the mean, and obviously this is accelerating from 2000, which is the start of the series observations, and right up to 2022 here. This vertical set on the right-hand side of the poster presentation, this is the cryosphere. The snow and ice parts of the planet. We start with Arctic sea ice from 1991 from BAMS, and you see the progressive rapid decline in Arctic sea ice. This is the summer minimum, which occurs in September, and the dotted lines are the March maximum. They're both decreasing rapidly. Here we have Antarctic sea ice, and Antarctic sea ice over the period of observation since 1980 went up and down, but it really didn't change any until very recently. And there's now a big decrease in Antarctic sea ice over the southern hemisphere summer. And in actual fact, this year, 2023, there was a record decline loss of Antarctic sea ice. So next we've got the ice sheets. These data are from Copernicus. This is the mass of the Greenland ice sheet, 1970 down to 2022. So this is the Antarctic. We have West Antarctica. The most part of the continental Antarctica is the East Antarctic. The West Antarctic ice is declining rapidly, accelerating rate again. Not least, I end up with the cryosphere with permafrost. But this is from the state of the cryosphere, published in November of 2023. That's from the Cryosphere Science Team. And very appropriately, they have a message, which is the message from the cryosphere, and the message is that this insanity cannot and must not continue. So all of the increasing climate change indicators, an accelerating rate, all-time high, is all totally insane. Because if it carries on, there's only one end result, and that is breakdown, collapse of the climate system. And as I've been presenting at the science conferences over a number of years, taken together, all these climate indicators indicate that the biosphere is on a trend towards collapse. So permafrost, obviously this is very, very important because this is a massive store of planetary carbon. So this is an image from a 2022 paper. So you can see emissions of CO2 and emissions of methane as the Arctic is warmed. Arctic amplification, the Arctic's warming faster than anywhere else, now to 4 times the global rate of warming. The blue is methane and the red is CO2 emissions. So these are the various sources. And all those sources of feedback in the Arctic are operant. They're all emitting more, and that includes the permafrost. So this is from NASA. This image is from NASA 2019. They had a short article here explaining that permafrost was becoming a carbon source instead of a carbon sink. And this was first brought to my attention in 2016, the NOAA Arctic Report Card, and they have a really good illustration explaining how both methane and carbon dioxide is emitted by thawing permafrost, and all of the permafrost regions are thawing and producing a lot more carbon dioxide than was ever anticipated. And so this had flipped the situation from a relatively small carbon sink in the Arctic to a carbon source. So I think the conclusions and recommendations are pretty obvious. All indicators are record high. That's a record adverse high. They're increasing faster than they ever have before. That includes all of the emissions. Recently, the rate of emissions has increased, and it includes the atmospheric greenhouse gas concentrations. So increasing at record rates, and altogether, that's a trend to biosphere collapse. Everything's getting worse faster. However, governments are pushing fossil fuels, pushing for more extraction, more combustion, more massive fossil fuel extraction projects being opened up across the world. And that's to the extent of the $7 trillion a year in fossil fuel subsidies. So the recommendation is we have to have a powerful intervention to stop what our governments and corporations are doing to us. And the powerful influence that we have is the national academies and the royal societies. Their mandate is to advise, recommend to governments. And so this is the science emergency situation of all time. And we need an emergency response direct from the science academies and the royal societies to their governments. And they must be told what to do, which is to put emissions into immediate rapid decline, and what not to do, which is to immediately stop all fossil fuel subsidies unconditionally. And the rapid decline must be directed at a total phase out of fossil fuels. No fossil fuels by 2050. The policy is following what is called net zero. But net zero has to be defined, and it has to be defined specifically by including a total phase out of all fossil fuel energy. So fossil fuel energy extraction, production, and fossil fuel combustion must cease, and that's being referred to as the phase out. Thank you for listening. I'm Peter Carter for the Climate Emergency Institute.